So for ODAS, a lot of it is right away. We do homeowners association. The big driver today is capacity for data. And what we're seeing across the country is difficult terrains, national parks where you can't build a tower. Even if you can build a tower, you can penetrate those areas or those canyons with RF. For IDAS, public venues, we did Amway. We have Pittsburgh Penguins Arena. Right now, we're in the process of doing Stanford University. Stanford, we deployed over 2 years ago. We have 23 outdoor nodes. At that time, we were working on the stadium. In the stadium, we only had one node covering the stadium. But with the advent of the iPhone, that's what triggered 3G and created capacity problems for the carriers. And Wi-Fi, we see it as a big item in a toolbox to offload capacity for the network, for the wireless service providers. Now we'll talk about Amway. Amway sits about 875,000 square feet, seating capacity about 20,000, and it's 8 distinct levels. And one of the things we found out about universities and arenas and public arenas here is that within that arena, there's different demographics. To give you an example, when we did Stanford Stadium, when we looked at the sectorization plan, we were getting live stats, and the student section was actually killing the network as far as data usage, as opposed to the visitor section where everyone was there to watch the game and maybe an occasional phone call. But that dictates what the design should be for that venue, and it's very, very difficult because we're placing a lot of RF, a lot of antennas to cover a confined area. There's a law, Shannon's law, that basically states you have to, in order to maximize your data throughput, you have to control your noise. And it depends on the area, the venue, what part of the country. If you're in a rural area, your noise floor could be neg 110, but if you're in downtown Manhattan, it could be neg 75. An example of Amway Arena, that's one of the things you have to benchmark your design is how strong are the existing macro sites getting into the venue, and that dictates what your design plan should be. So Amway is different, could be different from Madison Square Garden, because Madison Square Garden has a lot of buildings going in there, blasting, so the noise floor in Manhattan could be neg 65 dBm, so that's your benchmark. But in Amway, it could be neg 85, so that drives your design requirements. The big thing, whether it's a stadium or arena, is the soft handover or soft handoff regions, and basically the overlap between antennas. So if you look at a traditional site in a rural area, sites are about 5 miles apart, so the overlap is minimal. You go to a suburban area, macro sites are a mile apart, some overlap. You go to dense urban, sites are about half a mile apart, so there's a lot more overlap, but that overlap hurts you from a capacity standpoint. Now you go into an arena where it's not a half a mile, it's feet, hundreds of feet, and you have to minimize that overlap, and that's one of the challenges that we're encountering today, is to minimize that overlap, because when we do that, we improve on the signal to noise floor, and by doing that, you maximize your capacity gain and data throughput. And like tower siting or outdoor DAS siting is, a lot of instances we can't place the antennas where we would like to. So in this instance, we were relegated to the catwalk because they did not want to see the antennas. So there, we had some design challenges because the catwalk is hard to control some of the soft handoffs. So we play with the antennas, we down tilt, change antennas output, Yagis, and try to optimize that venue.